Good morning, students. Today our topic is Introduction to Exercise 1.3 in Sets. Let's go into the topic. What is the first topic? The topic is subset. What is subset? A set A is said to be a subset of a set B if every element of A is also an element of B. Let us having an example. If A is equal to set of 1 comma 2 and B is equal to set of 1 comma 2 comma 3. So we can say every element of A is also there in uh, set of B. So then we can say A is a subset of B. A is a subset of B. We can simply say A is a part of B. And the subset of is denoted by this symbol. You can use this symbol for denoting subset of. Let's having one of the example. So in this example, if you observe that A value is set of 1 comma 3, B value is set of 1 comma 5 comma 9, and set of C value is 1 comma 3 comma 5 comma 7 comma 9. And the first one, if you observe the first one, A is not a subset of B. A is not a subset of B. Why? The elements 1 comma 3 are not present in B. So 1 is there, but 3 is not there. But in the definition, we said like every element should be there in B. Then only we can say A is a subset of B. If you observe the second one, A is a subset of C, as 1 comma 3 belongs to A also belongs to C. If you observe that this A values having the elements 1 comma 3 and the set C also having the elements 1 comma 3. And the third one, B is a subset of C, as each element of B also an element of C. So 1 comma 5 comma 9 is present in B, also present in C. That's why we are saying B is a subset of C. And the last one, fourth one, pi is a subset of every set. Pi is a subset of every set. Let's having few important notes. What's the first one? A belongs to, A is a subset of B if small a is belongs to A, that implies A belongs to B. Suppose if A is equal to having the value A and B is equal to having the values A comma B comma C, then only we are saying A is a subset of B. That means small a belongs to A, that implies small a belongs to B also. Okay, this is the point we are writing here. And that's second one. Every set is subset of itself. Every set is a subset of itself. So that means A is equal to having A value. So what are the subsets of A? We are having null set and A. These two are the subsets of A. That means every set is a subset of itself, and pi is also a subset for a set. This is the pi. We can call it as null set or as pi. And the next point. What is the next point? So let A and B be two sets if A is subset of B and A is not equal to B, then A is called a proper subset and subset of B, and B is called a superset of A. If you let us examine this one. So A is equal to, we are having the values 1 comma 2 comma 3 and B is equal to 1 comma 2 comma 3 comma 4. So if you observe these two, A is subset of B and A is not equal to B. So both the condition they are satisfying because A value is 1 to 3 and B value is 1 to 3 comma 4. That's why A is not equal to B. So we can call A is proper subset and B is superset. let's go into the example. Let A, B and C be three sets if A belongs to B and B is subset of C. Is it true that A is subset of C? If not, give an example. They're asking one of the condition. If it is true, there's no problem. If it is false, then they are asking us one of the example. So definitely it is false. So let's go to the example. Now, let A is equal to set of 1 and B is equal to set of set 1 comma 2 and C is equal to set of set 1 comma 2 comma 3. So we can call 1 as element in A, and 1 itself it is set or subset. Okay, here itself it is element. So what is element here? One value would be the element. Here the whole value set of 1 would be the element, and thus in C also set of 1 would be the element. So now if you see the second one, A is belongs to B. A is belongs to B. That means this A is belongs to B. So in this B we can write B is equal to set of A comma 2, because A values set 1. Okay, A is belongs to B as A is equal to the value set of 1, and B is a subset of C. B is a subset of C. That means these two values are present in C. That means B is a part of C. That's why it is a subset. B is a subset of C, but A is not a subset of C. Okay. So if you see C value don't have the element 1, as 1 is belongs to A and 1 is not belongs to C. Okay. Going to the next topic. Intervals as subsets of R. Okay. What is R? R means real numbers. In real numbers, A is less than B and A comma B R belongs to capital R. So let's call it as intervals. And the first one is open interval. So both sides we are having open interval. It is closed interval, and here itself close and this side open. Here open and this one closed. Okay. So we denote like this. Let's go into the values. A is less than X less than B, then it is called open interval. If A is less than or equal to X less than or equal to B, then it is closed interval. And here A is less than or equal to X less than B, we can have closed and open interval. And A is less than X less than or equal to B, then we have open and closed interval. So here we are having few examples. So 2 less than X less than 4. That means the value of X would be in between 2 and 4, not 2 and not 4. That means we can simply say 3. And in the next way, in the next closed interval, X value is less than or equal to 2 and less than or equal to 5. That means 2 and 5 also will include, like 2 comma 3 comma 4 comma 5. In the next interval, we are having 2 less than or equal to X less than 5. So that means 2 will be included, 2 comma 3 comma 4. 5 will not include. In the next interval, we are having 3 less than x less than or equal to 6. That means 3 less than x less than or equal to 6. So the values would not be 3. So we are having 4 comma 5 comma 6. Okay, these are the values we are having in that intervals. Okay, let's go to the next topic. Number of subset. How do we find number of subsets? So number of subsets is equal to 2 to the power of n of a. So if a is equal to set of 1 comma 2, n of a is equal to 2. So these 2 would be the element count. These 2 would be the element count. So number of subsets is equal to 2 to the power of 2, that is equal to 4. What are those we are having? Pi is a subset of every set. That's why the first one we are having pi, and the second one 1, 2 and 1 comma 2. So this one is every set itself, it is a subset, and it is by these two are proper subsets of A. Okay, the next one, universal set. What is universal set? A universal set is a set which contains all the elements or objects of other sets, including its own elements. Okay, it is usually denoted by the symbol U. And we can say like a set containing all the sets are called universal set. We can say a set containing a set containing all the sets are called as universal set. Okay,